Let's remove the mystery right away. AI is not thinking, it's not reasoning the way humans do, it's not understanding language in any meaningful sense. What is going on is this: it takes an input, converts it into numbers, runs those numbers through a very large mathematical function, and produces an output that statistically matches patterns it has seen before. That's it. If you understand those three steps, convert to numbers, run through a function, produce probabilities, you understand how modern AI works. Everything else is just scale and engineering. Let's now break those systems down. Computers don't work with words, they work with numbers. So the first thing any AI system does is convert input into a numeric representation. Let's say you type, "The cat sat on the mat." That sentence is broken into pieces called tokens. A token might be a word, part of a word, or even punctuation. Then each token is mapped to a number. For example, the maps to 1024, cat maps to 5821, sat maps to 912, etc. Now your sentence is just a list of integers, but integers alone don't carry meaning, so we go one step further. Each token is converted into a vector. A vector in this context is just a list of numbers. Cat here maps to 0.12, negative 0.98, 0.33, potentially many other values, and ending in 0.07. This might be hundreds or thousands of numbers long. This is called an embedding. The key idea: words that appear in similar contexts get similar vectors. So cat and dog end up close together, king and queen end up close together, but car and banana are far apart. Not because the model understands meaning, but because it learns statistical relationships from massive amounts of text. So now your sentence is no longer words, it's a sequence of vectors. Now we feed those vectors into a neural network. At its core, a neural network is just a function. Output is equal to f of the input. But instead of a simple function, it's made of many layers. Each layer calculates. Output is equal to the activation of weights times input plus a bias. Let's break that down. The weights are numbers that control how important each input is. The inputs are your vectors. Bias is a small adjustment to set the baseline starting point before looking at data. Activation is a function that adds nonlinearity to decide how much of the info should be passed forward to the next layer. So the model takes your input, multiplies it by weights, adds bias, and applies a function. Then it passes that result to the next layer. This happens hundreds of times. Older models processed text one piece at a time. Transformers changed everything. Instead of processing words sequentially, transformers look at all tokens at once and determine relationships between them. This is done using something called attention. Attention answers this question: for a given word, which other words matter? For example, consider the sentence, "The animal didn't cross the street because it was too tired." What does it refer to? The model learns to pay attention to animal. Mechanically, attention works like this. Each token gets three vectors: query, key, and value. Then the model calculates how similar the query of one token is to the keys of all other tokens. That similarity determines how much attention is given. Mathematically, attention equals softmax of q times k to the t over the square root of d sub k times v. Don't worry about memorizing that. Softmax converts raw attention scores into a probability distribution between 0 and 1, ensuring all focus weights sum to 100%. The important part: each word dynamically pulls information from other relevant words. This is why transformers can handle context. At the end of all these layers, the model outputs probabilities. Specifically, Given the input so far, what is the probability of each possible next token? For example, consider our previous input text. The cat sat on the model might output mat equals 0.65, floor equals zero point 0.2, chair equals zero point 0.05. The model doesn't start with knowledge, it starts with random weights. Training means adjusting those weights so the model makes better predictions. Here's the process: give the model a sentence, hide the next token, let the model guess, compare the guess to the actual answer, measure the error, then adjust the weights slightly. This adjustment is done using gradient descent, which is moving the weights in the direction that reduces error. Repeat this billions of times across massive data sets. That's how the model learns. The model doesn't understand language, but it has seen so many patterns that it can produce outputs that look like understanding. For example, it knows that questions are followed by answers. Code has structure. Explanations follow certain patterns. So it reproduces those patterns extremely well. What feels like reasoning is often just very high quality pattern matching. Because it's pattern based, it can confidently produce incorrect answers. It can hallucinate facts. It has no internal truth checking. It doesn't know when it's wrong. It's predicting what looks correct, not what is correct. Everything we've described scales. More data leads to better patterns. More parameters results in more capacity. More layers produce more complex relationships. That's why modern models are so large, not because complexity changed, but because scale amplifies performance. Let's summarize the entire pipeline: input text, tokenization, convert tokens to vectors, run through transformer layers, use attention to relate tokens, output probability distribution, select the next token, and repeat. That's it. No magic, no hidden intelligence, just a very large statistical system. In closing, AI feels intelligent because it mimics the structure of human communication extremely well. But under the hood, it's doing linear algebra, matrix multiplication, probability estimation over and over again at massive scale. If you understand that, you stop being impressed by buzzwords and you start understanding what the system can and cannot do. In your opinion, are people overhyping AI or not? Let me know why in the comments below. If you found this video helpful, please like and subscribe.